Hey guys, welcome to 4.4c, solving by factoring. For this one, what we are doing is we are solving using factoring techniques that we've learned throughout this unit and some from the last unit. So let's go ahead and do a little bit of review before we get into the actual solving. If you look at the review problems A and B, notice that the first one, 25x to the fourth minus 36, 25 and 36 are both perfect squares. And since we only have two terms, this is going to end up being a difference of squares. So we do our double parenthesis to start out. We know that 25x to the fourth has to come from 5x squared for both terms. And then the 36 part comes from 6 and 6. And since it's a difference of squares, we get one of each sign. Now make sure you look at these terms, even though we factored it down. Can you take anything further? And in this case, we're as far as we can go with this problem. So this is our answer. Now let's look at B. B can be a little confusing. We haven't done a ton like this, but this is where there's more variables than just our typical one. If you look though at every single term, everything has at least a b squared to it. So we can actually factor out b squared as the GCF. Then we're left with a squared minus 8ab plus 16b squared. Now that we have the b squared out, we can actually factor what's inside the parentheses down into two separate parentheses. We know that a squared has to come from a times a. And if you look at the last term, it's 16b squared, which is a perfect square. We know the signs are the same, both negative. So what the square root of 16b squared is 4b. And 4b again. And when you take 4b times, or negative 4b times a, and then add that to another negative 4b times a, we do get negative 8ab. So this one does work, and this is as far as we can factor that down. Now look at the difference for example 1. Solve for all solutions. It's equal to 0. Whenever we're solving, we want to get it equal to 0. The first problem here, 2y to the fourth minus 18y squared, notice that we can factor some stuff out. We can take out a 2 from both terms, and we can take out a y squared. Then we're left with y squared minus 9 equals 0. Now we can actually take y squared minus 9 a step further too. So keep the 2y squared on the outside, and that's a difference of squares, so y plus 3 and y minus 3. Now remember that each part should give us a solution. So we can start with the 2y squared. You might want to set this one equal to 0. Divide it by 2 on both sides. We get y squared equals 0, because 0 divided by anything is 0. And even though we take the square root to solve for just plain old y, it doesn't matter if we get plus or minus 0. This is what's considered a double root. So we get 0 as our only answer on that side. And then y plus 3, well, we know that the opposite of plus 3 is minus 3. And y minus 3, the opposite of that is plus 3. Same idea as what we were doing in the last unit. So let's go ahead and try this next one here. This one, we have to recognize that now we have two perfect cubes. This is where we have to know that pattern that we talked about in 4.4a. This is a special pattern. This is that a cubed minus b cubed equals, you will need to have this memorized for your test too. Just keep that in mind. A minus b times b squared, or a squared plus a times b plus b squared. Okay, so that's the special pattern. Let's go ahead and figure out what that is. So a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. We need to figure out what a and b are to start this out. So if a is our x cubed, what number would we cube to get x cubed? It would be x. And then b is our 27, and we know that you have to cube 3. Some of these numbers should definitely come back pretty quickly because we use them a lot. So now let's follow this pattern here. We know we're going to get x minus 3 to start, and then a squared is going to give us x squared plus a times b, so x times 3 is going to be 3x, plus b squared is 3, so 3 squared we know is 9. Now that's not enough to finish. For this one, x minus 3, then x squared plus 3x plus 9. If you recall, we can't factor x squared plus 3x plus 9 any further. In order to solve for that one, we actually have to use the quadratic formula. Technically, we could do the difference of squares method too, but I'm assuming most people are going to want to use the quadratic formula for that problem. So let's go ahead and do it for this. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we fill it in. Negative b would be minus 3 plus or minus the square root. Oh, I should have done the discriminant first. So b squared would be 9 because it's 3 squared minus 4 times 1 times 9. So we get 9 minus 4 times 1 times 9 is 36, and that ends up being negative 27. So we get the square root of negative 27 all over 2 times 1, which is 2. Negative 27 should jump out at you. We can break that down into 9 and 3, and then 9 breaks down into 3 and 3, but it's also a negative number, so we have to pull out an I. We get x equals negative 3 plus or minus, we can also pull out a 3 since there's a pair of 3's, so 3i, and then what's left is this 3 right here inside, all over 2. Now this is 2 of our solutions. This is the solution to this part right here. Now the reason I said you had to use the quadratic formula is because of that imaginary number. I knew that we were going to get an imaginary number for this, and you always will when you have these special patterns. But the x minus 3 part, that one we don't have to work hard for. We know that the solution to that is just 3. It's just the opposite. So we actually have 3 different solutions for this problem because the second part has a plus or minus. Okay, I'm going to do a couple more with you, and then I'm going to have you try example 3 on your own. All right, example 2. X cubed plus 2x squared minus 9x equals 18. Again, we want to get this equal to 0, so let's move 18 to the other side by subtracting. We end up getting x cubed plus 2x squared minus 9x minus 18 equals 0. X cubed plus 2x squared minus 9x minus 18, that is a cubic equation. So we can't just jump to conclusions here. You can't use the quadratic formula or anything like that. But if you notice, this is just like what we were doing in the last video. So we can factor by grouping. So let's take out an x squared to start. Look at the first 2 terms. We get x plus 2. Then we look at the last 2 terms. We can take out a negative 9, and that's also going to give us x plus 2. Now we can combine our ideas here. We would get x squared minus 9, because we put the terms that are in front, and then we have the x plus 2 equals 0. So x squared minus 9, x plus 2. X squared minus 9 is a difference of squares, so it's x plus 3, x minus 3. We are going to get that difference of squares a lot, so make sure you're on the lookout for those. And then we have the x plus 2. So now that we have it all factored down, the solutions, I'm just going to write them up top here, to x plus 3 would be x equals negative 3, positive 3, and negative 2. Just the opposites for all of those. Once you get it factored down completely, it's pretty quick to just find the answers. It's not much more work than what we were doing in the last unit. Okay, I'm going to do this next one here with you. 16x to the 4th equals 81. For this one, again, we need to move that 81 to the other side. We end up with 16x to the 4th minus 81 equals 0. For this problem, 16 and 81 are both perfect squares. So this is just like what we were doing up here in the first review problem, part A, because it's x to the fourth. So let's get the double parenthesis equals 0. We would get 16 comes from 4x squared and 4x squared. 81 comes from 9 and 9. And we get one of each, plus and minus. So now you can't break up 4x squared plus 9, but we can break up 4x squared minus 9. So 4x squared plus 9, we're going to leave it on its own for right now. The 4x squared minus 9 is another difference of squares. We can break that up as 2x plus 3 and 2x minus 3, because it's, again, two different squares. All right, now the 4x squared plus 9. The reason we can't break that up is because we're actually going to get an imaginary solution for this. What we're going to do is we're going to pull this part out, and we're going to set that equal to 0 now that we have it separated. If you recall, we can solve this by the square root method. So if we subtract 9 from both sides, we get 4x squared equals negative 9. Then we can divide by 4 on both sides. Leave your answer as a fraction here, because if you recognize 9 and 4, those are both perfect squares. So when we take the square root of both sides, we're going to get x equals plus or minus. Now notice it's a negative number, so we know that we're going to get an I in here. But the square root of 9 is 3, and the square root of 4 is 2. So we get plus or minus 3 over 2 I. Now what we're going to do to get the answers for these two is just set one of them equal to 0. Subtract 3. We get 2x equals negative 3. Divide by 2 to get x by itself, and we get x equals negative 3 halves. And since these just have the opposite sign, since this one was negative 3 halves, we know the other one's going to be positive 3 halves. So there's actually 4 different answers out of this. And that was a lot of work just to break it down from 16x to the fourth minus 81. You have to be really careful about these. They're not easy. We have to remember a lot of our factoring techniques. Okay? So you only have the one problem to do here, this 8x cubed plus 125 equals 0. If you recognize that, it's going to be one of these special patterns, like what we had up here. I'm going to write out the pattern here just to save you some time. So this is going to be a cubed plus b cubed, which equals a plus b, a squared minus ab plus b squared. So I'm going to let you figure out what a and b are, fill out that, solve for the different answers. But remember, for this part here, once you get it broken down, you're not going to be able to factor it. You're going to have to use the quadratic formula because you're going to get imaginary solutions. So just keep that in mind. All right, go ahead and do that problem and submit your notes when you're done.